All right, so this is 12-4. We're going to go through a quick review of what we've already talked about. So to graph a quadratic, there's a couple things that we need to do. The first method, which in your homework I gave you very specific numbers. The first method that we're going to use is the table method. And that's where I set up a table. So what would I need to do to graph this? How would I go about? Explain to me the process. RJ. Make an XY table. Now from here, at this point, what do I need to do? Anybody? RJ?
Pick random x values.
Pick random x values. So I'm going to choose -3 to +3. I substitute those in for the x, and then I solve for y. So -3 squared is 9. And then I plot that point. -2 squared is 4. And then I plot the point. -1 squared would be 1, and then I plot the point. 0 squared would be 0, and then 1 squared, I get 1. Now, the thing about this, at this point, what do we call this point on our graph right here? It has a special name for it. What do I call that? Yeah. Neve? Okay. The vertex. That point is the vertex. But you know what, Neve? You're also right in that the vertex is the bottommost point or the uppermost point, the highest point, the maximum, or the lowest point, the minimum, in a parabola. And the parabola also has something called an axis of symmetry, which is this that splits it in half. So that is our axis of symmetry. And this is my vertex. I'll change the color to the vertex can be in yellow. Okay, that's the vertex. Okay? Now, the gift in the parabola is that you have matching points. If you have an axis of symmetry, that means it cuts the parabola in half. And once I've reached my minimum here at 0, 0, then I know everything opposite, it's going to be a matching point to the other side of the axis of symmetry. So notice, this point is 1 unit over. So this is going to be 1 unit over at the same height. So this is -1, +1. I'm going to go +1, +1. Notice I'm 2 units over right here from this axis of symmetry. So I'm going to count over 1, 2 units over here. You with me? So now I'm how many units over at that top point? How many units over, Ben? 3. So I'm going to count over 3 units over here. And what I have are these 3 points on the right-hand side of that parabola are like free points. I don't have to do the math and keep doing the table. Do you understand? And then I draw it. I connect the points. And it's going to be kind of tough, so I do suggest using a pencil. Actually, mandatory pencil. And it goes on and on forever in the upper direction. Now, the critical features that you must have every time you're graphing. You must have your vertex. You have to have an axis of symmetry. Yes, I want them labeled. You need a y-intercept. Okay? And you need at least 3 points, preferably more, to draw a more accurate parabola. So usually like 5 points. Okay, am I forgetting anything? Axis of symmetry, vertex, y-intercept. Okay, can I erase this? You're going to get the chance to write all this again. All right, so now I'm going to erase, and let's look at some graphs. Now, I could keep doing my math and find these other points, but why not take the free points? Do you understand what I'm saying? If you know that there's one on this side and one on this side, why do the math if we know a quadratic, it's going to have the same y value? Okay. And note that this is a U. It's not a V. V is absolute value. So we don't want to make it look like a V. Okay. Now, what's happening? I'm going to just skip through the table of this. And let's look at the graph of this. The last one was Y. Actually, let's look back here. Notice our vertex. Where is it? It's at the origin, 0, 0. Okay? Now, if I go on to the next one, x squared minus 5, what's happening to my parabola? It's been shifted down. The y-intercept is -5. It's not linear.
Well, not a linear equation, but like it uses that like the same kind of format because it has a constant, which is the y-intercept.
Okay, so we're shifting it down. Okay? I'm going to pass through this. If you need to practice your order of operations, you can stop the recording. Now, look at the equation. What's different about this equation than what happened before? Jesse?
That x squared is negative, so it's going to be going down.
It's going to flip down. It's going to be upside down. Also, what's that positive 4 going to do? Dennis?
It's going to make the vertex higher?
Yeah, it's going to shift it up 4 units. So let's look at it. It's shifting the vertex up 4 units. Now, is this a maximum or a minimum? Maximum, because it's the highest point. Okay. Now, so the +4 shifts it up. The -5 shifted it down. Now let's look at when I have a coefficient that's greater than 1 for the x squared term. Now, if you ever get lost, you can always go to the table method. Now, what did the 2 do to the parabola, Jessica?
It made it more narrow.
It made it narrow. It makes it skinny. So if the coefficient of A is a whole number greater than 1, it makes it skinny or narrow. Now, where's my axis of symmetry this time? Just out of curiosity. Grant.
On the x-axis +1, or 1.
Just at 1. We say it's at where does it go through? It goes through 1. The axis of symmetry is through 1. Yes.
And it's through 1 because it's a negative for x. Because there's a value for the b.
Well, that's not y.
Wait,
It's going to be wait, just hold on. Okay. So, right, but don't jump ahead while I'm recording, okay? All right, so my decimals, what does it do to the parabola? Okay, yes.
It makes it wide.
Makes it wider. So we talked about this. It's making it wider. So let's look at it. A decimal value. It doesn't matter if it's negative or positive. It just makes it wider when the number is less than 1 and greater than 0. It can be negative decimal or a positive decimal. It's still going to be wide. The negative and positive just tell us whether it's going to flip up, it opens up, or whether it opens down. What is the vertex here, by the way? Josh Plattner. No, the vertex.
It's
2, 1. And another way they could ask you that on tests is, what is the maximum? Okay? They might just say, what is the maximum? All right, so the quadratic equation. This is the part I want you to write. If we've written it already, we're fine. But if you haven't, make sure you have it. Remember, ax squared is our quadratic term. Bx is our linear term. And c is our constant. Okay. So we said if a is positive, what happens? If the coefficient of x squared is positive, what happens? It opens up. If a is negative, it opens down. Okay. If a is a number that's bigger than 1, what kind of parabola will it be, Minky? It'll be narrow or skinny. Okay? If a, Josh Kim, is less than 1 but greater than 0, the absolute value is less than 1 but greater than 0, what kind of parabola will it be? Anybody? Josh Thomas? It'll be wider or fatter. Okay? It'll be a wide parabola or fat parabola, my second period likes to call it. It's a big fat parabola. Okay? So Josh, do you understand that? You sure? So the coefficient of x squared, if that is a decimal amount, it'll be really wide. Okay? If it is a number greater than 1, it will be very narrow. Now the last part was the y-intercept. C is always our y-intercept. If it's positive, it shifts the y, it's shifted up. The parabola is shifted up. If it's negative, the parabola is shifted down, or the vertex is shifted down. Okay, questions? Pause the recording if you need to take notes. All right, so our critical features of a quadratic. Now, let's look at this. If I do the table, okay, so remember I said to you, you need a vertex. You need a vertex. What is the vertex here? If I do the table method, I still need these features. Oh my God. So what is the vertex here? All right, what's the vertex here? Kevin? Okay, the vertex is 3, -7. What's my axis of symmetry? Let's go, Grant. 3. It's crossing the x-axis at 3. Good. Where do we see that? Where else do we see a 3? I know that our axis of symmetry is 3. Where else do I see a 3, Jesse?
The vertex, the points, the x.
The x is 3. So the axis of symmetry is not only x, does x equal 3, but it's the x in the vertex. Okay, so let's look at this. So when you're given an equation, you have to find the critical features. First thing you need to do is find the axis of symmetry. And so the formula is x equals negative b over 2a. Okay? Now what does that mean? Remember we said y equals ax squared plus bx plus c? So I take, what is the a value? What is the a value, Ben? A is 1. What is the b value in this equation? Negative 6. And what is my c value? Positive 2. And then I substitute in. So this is a formula. It's mandatory. You'll not get through your CSTs without having this memorized. So you need the axis of symmetry. So I do negative b, I substitute in negative 6. And remember, I already had a negative there, so it's really going to be negative 6 over 2 times 1 is a. And when I multiply that out, the value of it is 3. Okay? You should be writing this. So now, we said that x, we said that x is equal to 3. It's the axis of symmetry. It's also the x where? In the what?
The problem of the vertex.
In the vertex. It's also the x in the vertex. So, I'm going to use that. I know that my 3 is the axis of symmetry is the same thing as the x in the vertex. And now, to finish finding the vertex, I have to solve for y. So I'm going to use that x, substitute it into the equation, okay? And I'm substituting in the 3 for all the x's, and I'm going to figure out what my y is, solve for y. So 3 squared plus minus 6 times 3 plus 2. So y is equal to what?
Well, y is equal to negative 7, negative 7, but where does the c come
Wait, hold on. So, now, y is equal to negative 7. So, what is my vertex?
3 negative 7.
Stacy.
3 negative 7.
3 comma negative 7. So, now I have my vertex. Next. Okay. Does this open up or open down? Neve. Does this open up or open down? Okay, does it open up or open down? How about Stacy?
Opens up.
Up. So Neve, I have to look right here on the x squared. Is that positive or negative?
Positive.
Okay, it's positive. So, hold on, I'm trying to write on this, and I'm having technical difficulties. All right, here we go. So I'm looking at this. If it's positive, it's going to open up. If that x squared is negative, which way does it open, Neve? Good. So now I'm going to, so we know that it's positive, so it opens up. Now, what can you tell me about the y-intercept? What is the y-intercept? Dennis. The y-intercept is positive 2. Okay? So these are the things we have to look for every time we're graphing. Wait till we get to the graphing. We're going to do that at the end. You have to be able to find these things. Okay? Yes?
So with linear equations, the b is the y-intercept, and then with quadratic equations, c is the y-intercept?
Yeah. Okay. All right, so let's try another one. What do I do first? Neve, stay with me. What am I doing first? Ben, I know you know this. I want this for the rest of the class. Okay. Matthew Bernard. X equals negative b over 2a. All right, so we're using x equals negative b over 2a. Okay, Neve, what's my a, my b, and my c? What's my a?
Your A is negative 4.
Good. What's my b?
8.
b equals 8. And what's my c?
1. Or 2. Oh.
Is there a number all by itself? Josh?
0.
It's a 0. There's nothing there by itself, so it's a 0. So C equals 0. So now I want you to pause. I won't pause the recording, and you try and find the axis of symmetry. Go. All right. So what do I substitute in? Jacob Vogel.
Alright, well, for the negative b, you would substitute in 8, and then it would be negative 8
Over?
over 2 multiplied by negative 2, which is negative 4, so it would be negative 8 over negative 4, which simplifies to 2.
Positive 2. Okay, what do I do with that next? What do I do with that? Zoe?
You find the vertex?
Okay, so that is what? What is that 2? How do I go about finding?
2 comma y.
2 comma y, so that's the 2 in my vertex, the x in my vertex, sorry.
Yes, so you put in the equation y equals negative 2x squared plus 8x, and put in the 2 for the x and solve.
Good. Okay, so now, why don't you, I'm going to pause the recording and I want you to solve for y. All right, so negative 2 times 2 squared makes what? Negative 2 squared is,
2 squared.
sorry, 2 squared is 4 times negative 2 is negative 8 plus 16. And so y is equal to, Devin?
Y is equal to 8.
Y equals 8. So, what is my vertex? Neve. 2 comma 8. Now, what else do we need to know about this? I want to hear from some other people. Susan,
If it opens up or down,
does this open up or down?
it opens down because
It opens down because
it's negative.
it's negative. The quadratic is negative. Okay? And what is my y-intercept here? Y-intercept. Let's go, Zoe.
It's 0 because c equals 0,
Okay, it's 0 because c equals 0.
so it's at the origin.
Okay, so it is at the origin, yes. I'm glad she's visualizing this. I don't know what's going on. All right, I'm going to move on, and we're going to move away from this, and we're going to go on to the graphing. Did I hear a big oh? Okay, so my y-intercept is 0.
Ms. Kawasaki,
Yeah,
go to the next slide really quickly.
sure.
So, to find the x, what if you solve for x by setting, oh, never mind.
We're going to get that. We're getting there now, okay? All right.
Because that's what I had to do with the addition.
Okay. Yeah. All right, so I've given you a worksheet, and I'm going to give you an easy problem to graph. Okay, this works out very nicely. Most quadratics are not as friendly and nice as this. Yes. Okay, so I'm going to give you the equation. Y equals x squared plus 6x plus 8. Okay, so step 1, I want you to identify your A, B, and C. Who can tell me what the A, B, and C is? Grant.
The A is 1, the B is 6, and the C is 8.
Okay. Next step. Notice the worksheet's telling you everything you have to do. Step 2. Find the axis of symmetry. Okay? So what am I substituting in here? Neve?
Well, we're substituting our A, B, and C, and our A is 1, so, or we can start from the top. So our B is 6, so negative on the corner is
6 over
2 times A, and A is 1, so 2 times 1 is equal to negative 6 over 2, which is equal to negative 3.
which equals negative 3. Now, what does that negative 3 become? How about Ulysses? Okay, how does the... All right, so now we've solved our B situation. Okay, so now the question is, what am I doing with that negative 3? What is that negative 3? Ulysses, I just called on you.
We're going to solve targeting the vertex.
Okay, and what is that?
That's the x.
That's the x in the vertex. Okay, and then how do I go for figuring out what my y is? What do I have to do? I'm going to substitute it into what? The original equation. Y equals x squared plus 6x plus 8. Okay. What do I substitute in? Keep going, Ulysses. Okay, and so I'm going to get?
Negative 3 squared plus 6 times negative 3 plus 8.
Okay. And y is equal to, what does that simplify to? Okay. Okay, 9. Keep going.
Plus negative 9 minus 18
Plus 8, and that is 9 and 8 is 17. Minus 18, so y equals negative 1. So now, I've got my axis of symmetry. I've got a bunch of information that I can really use. So my vertex is, Quetzali? Comma, negative 1. Okay, Neve, which way does it open?
Since we have since we have a positive, it opens up.
Up. Okay, axis of symmetry. Axis of symmetry. Let's go with Grant Blair.
Negative 3.
Negative 3. And what is my y-intercept? The y-intercept. Now, remember back when we were doing linear equations, we said to find the y-intercept, set x equal to 0. So I'm going to do that. X squared plus 6x plus 8. So 0 squared plus 6 times 0 plus 8. Now notice, this becomes y equals 0 plus 8. It really kind of negates these terms. Sorry. So once I substitute in, I can just go right for that constant term up here. Y equals 8. So what is the ordered pair here for the y-intercept? What would we say the ordered pair is? Stacy?
0, 8.
When x is 0, y is 8. So I could say it's 0, 8, or I could just say the y-intercept equals 8. Now I've got a few things to graph. Okay? So I'm going to start graphing what I have. I've got my, I have my vertex, which is negative 3, 1, 2, 3, and then down 1. I have my y-intercept, which is 0, 1, 2, 3, 4, 5, 6, 7, 8. Now, remember, we also have our axis of symmetry. What is that? Negative 3. So I'm going to draw, here's my axis of symmetry. Now that helps me to divide my parabola, so that's my axis of symmetry. And now, if I have this point, what other point do I have? And I have my vertex. What other point do I have, RJ?
Negative 6, 8. Sorry, not negative. Yeah, negative 6, 8.
Negative 1, 2, 3, 4, 5, 6, up 8. So I'm going 3 across. So I'm going 1, 2, 3, up 8. That's negative 6, positive 8. All right, I've got 3 points. To make it... All right, so now I'm going to... I've got 3 points. I have one more step to this video. And okay, so now I have 2 choices now. I can go back to my table method, and I left you an extra space down here. So let's say this is used for table. Okay? And I'm going to set myself up an XY table. And you can either do this or you can find the roots to find another point or 2. So let's say the equation was x squared plus 6x plus 8 is equal to my y. So I'm going to pick a number when x is negative 1. So negative 1 squared plus 6 times 1 plus 8 should equal my y. So I have 1 plus negative 6 plus 8. So I have 9 minus 6 is 3. So here's another point that I can use for my quadratic. I have negative 1, and I'm going up 3. 1, 2, 3. Now again, I have its mate on the other side of the axis of symmetry. So if I'm 2 units, I can go 2 units to my left. And now I can draw my quadratic. Okay? Now, another thing you can choose to do is to find the roots. And the roots, it's not really part of this lesson, but it's easy enough to teach right now, is your x-intercept. Okay, so we find the x-intercept by setting y equal to 0. So I do y equals 0, and then I have x squared plus 6x plus 8. And we go back to chapter 6, and we solve the quadratic for our 0 product property. What multiplies to 8 and adds to 6, I get x plus 4 times x plus 2 equals 0. And now, since it's the 0 product property, we have x is equal to negative 4, x is equal to negative 2. And those are my roots. We have a couple different names for that. Roots. We could call, these are our roots. These are our x's. These are our x-intercepts. These are our solutions. So if you notice, one root is at negative 2, right here. Put a point. And another root is at negative 4. 1, 2, 3, 4. And so again, those are 2 more points. Now you don't have to do both. You can use, if it's factorable, this was an easy quadratic and it was factorable and it gave me 2 roots, then you can do this. If it's not factorable or the roots are kind of in between, you might want to use the table method and find 2 other points. But you should come up with at least 5 points to graph the quadratic. And this is how you graph a quadratic. Looking to make this smaller.